Now this video is going to run us through some slideshows, which is the starting of chapter 2. And what we're going to be doing with is working with some language of the geometry and statements, not always of geometry, but statements of the form if something, then something else. So they're if-then statements of the form if A, then B, and they're always called conditional statements. As an example, if two lines are parallel, then they do not intersect. So this is a conditional statement. A, two lines are parallel. That's the A part. That's called the hypothesis. Then they do not intersect. They do not intersect is the B component called the conclusion. Okay, so that's stated over here a little bit more formally. If A, then B. A is the hypothesis, B is the conclusion. If three single points are collinear, then they lie on a single line. So the hypothesis, 3 points are collinear, conclusion, they lie on a single line. If two rays share a common endpoint, then they form an angle. So the hypothesis, two rays share a common endpoint. Conclusion, they form an angle. Okay, another statement. If 3 points are not collinear, then they are coplanar. Hypothesis, 3 points are not collinear. Conclusion, they are coplanar. If two lines are skew, then they do not intersect. Hypothesis, two lines are skew. Conclusion, they do not intersect. If a figure is a square, then it has 4 sides. Hypothesis, a figure is a square. Conclusion, it has 4 sides. Okay? Now let's look at writing some conditional statements. Okay? From a statement here. So the statement is a right angle has a measure 90 degrees. So we want to write this as a conditional statement that is with a hypothesis and then a conclusion. It might easily be stated as, if an angle is right, then it measures 90 degrees. Okay? So again, that's just putting it in the format of an if-then statement. Another one, two skew lines do not lie in the same plane. So in an if-then conditional format, if two lines are skew, then they do not lie in the same plane. A bisected angle contains two congruent angles, stating that as a conditional, if an angle is bisected, then it contains two congruent angles. I live in Philadelphia, Pennsylvania. Perhaps we could say, if I live in Philadelphia, then I live in Pennsylvania. Okay? Now, when the if and the then are switched, we generate something called converse statements. So the converse statements switches the if and the then components. It switches the hypothesis and the conclusions. That is, the hypothesis of one becomes the conclusion of the other, and vice versa. Let's take a look at some examples. If I live in Philadelphia, then I live in Pennsylvania. So often we want to check to see the validity of this. Okay, if I live in Philadelphia, then I live in Pennsylvania. That may or may not be true. There may be other Philadelphias. I do believe there's a Philadelphia, Mississippi. But if we just come and look at this in terms of the converse, okay, so if I live in Philadelphia, then I live in Pennsylvania. The converse is, if I live in Pennsylvania, then I live in Philadelphia. And that, of course, need not be true. But again, the idea is for us to take the converse, that is to switch up the if and the then components, but make it sound reasonable in terms of correct with your English language, that is. Okay, so again, this is not true. Okay, because you could live in some other city of Pennsylvania, Scranton, Harrisburg, where have you. Okay, another example: if two lines are parallel, then they do not intersect. Well, what would be the converse? Flipping the if and then would read, if two lines do not intersect, then they are parallel. Two lines do not intersect, then they are parallel. Now, this is not true because they could also be skew. So again, the original statement, if two lines are parallel, then they do not intersect, is true. Okay? Two lines are parallel, then they do not intersect. That is obviously true. But the converse, if two lines do not intersect, then they are parallel, is not true because we have the condition of skew. Let's consider this example. If two lines are skew, then they do not intersect. If two lines are skew, then they do not intersect. That is true. Let's consider the converse. The converse would be, if two lines do not intersect, then they are skew. This is the converse because it does switch the if and the then. However, it is not true because the lines could in fact be parallel. Let's look at yet another example. If a figure is a square, then it has 4 equal sides and 4 equal angles. So rewriting this in terms of a converse statement, if this is the original statement, that's called the conditional statement. And the converse statement is a statement which flips the if and the then component of the conditional statement. So the converse of this would be, if a figure has 4 equal sides and 4 equal angles, then that figure is a square. So that's what we write. And that should be true. Okay? So there you have, okay, your conditional statements, your converse statement, your conditional statements, if you will. Okay? Start off with a hypothesis and a conclusion, an if component followed by a then component, hypothesis and conclusion, as it were. Okay? You will at some point, and you might as well get used to it now, checking to see whether the statements are true. Okay? We can take simple facts and write them in conditional statements. So you should be able to do that. And then we can take a conditional statement and make a converse out of it by flipping its hypothesis and conclusion. That is, by flipping its if and then component. And in this case, we'd also want to check to see if in fact your conditional statement is true, and if in fact the converse statement is true. Okay? So that should be the conclusion of this video. We will look at that by conditional statements in the next video.